Let's look at conversion problems. So, some conversions. Here's a conversion. If you wanted to know how much a British pound was worth, we have a conversion of 1.632 plus 3 more zeros. That's how far they take the sig figs in US dollars. A euro, there's your British pound with the queen. A euro is 1.4249 US dollars. And I didn't update these for today. But that's something when you're in Britain or in Europe, you kind of do those conversions in your head so that you can try to figure out what something is really costing you in US dollars. Tomorrow, I'm going to give you what I call the Navy sheet that has a lot of prefixes on it. So, for example, you could look up the word milli, and you would see that it means 10 to the minus 3. So we could say there are 1,000, which is 10 to the third, millimeters in 1 meter. If we look at the word nano, nano means 10 to the minus 9th, which is 1 times 10 to the 9th nanometers in 1 meter. So there's a couple of different ways of using these prefixes. Say we had a measurement of 45 millimeters, and you needed to change it to meters. You could just look at that prefix and say, oh, that's 10 to the minus third. So if I substitute that in for milli, I have let's not mess with the scientific notation yet, 45 times 10 to the minus 3 meters. Now you can change that to proper scientific notation, and you would get 4.5 times 10 to the negative 2. Because you do need proper scientific notation. And you can use your calculator for that. Or you can just work through it yourself. You could also convert that by using 1,000 millimeters in a meter. It's really the same thing. You can take your 45 millimeters, doing this like I did in class today, 1,000 millimeters in a meter, and you get 0.045 meters, which is 4.5 times 10 to the negative 2 meters. Same answer. The second way is called dimensional analysis. So, dimensional analysis, sometimes called unit analysis, is how you use, how to solve mathematical problems using units. You always show your work, because I don't want you doing in your head. As I mentioned today, if you can use this dimensional analysis, you'll really be set up for when we do some more difficult problems. So, our first problem. A book is 14.57 centimeters long. Determine the length in millimeters using dimensional analysis. Well, use your blue sheet, and you can say, all right, there's 10 millimeters in 1 centimeter. So I'm going to start with my 14.57 centimeters, and I want to see that dimensional analysis. That's what I'm trying to have you practice. 1 centimeter has 10 millimeters. Things to notice. This is a multiplication sign. My centimeters are opposite each other, or kitty corner from each other. Mathematically, easy. It's 145.7 millimeters. We only consider the sig figs here. Any of these conversions, we're going to consider exact numbers. We don't have to count them for sig figs. Let's look at another problem. Problem 2. Convert 75 mils to liters using dimensional analysis. There are 1,000 milliliters in 1 liter. So start with 75.0 milliliters. Using dimensional analysis, I want my milliliters to cancel, my liters to be the units I have. We have 1 liter has 1,000 milliliters. Cancel your units. Mathematically, you have 0.075, put on the 0 for sig figs, and that is liters. And there's your final answer. You could change that to scientific notation if you wish. There's our third problem. Express 45 nanometers in meters. This time I'm going to use a slightly different technique. We're not going to use dimensional analysis, but if you know that a nano is 10 to the minus 9, I'll give you a sheet tomorrow which will help you find that. I'm going to take 45 nanometers, there's the abbreviation, and substitute in 10 to the minus 9th for the nano. So I have 45 times 10 to the minus 9th meters. That's improper scientific notation. So I need to, and you can use your calculator, it ends up being 4.5 times 10 to the minus 8th meters. Your value would be correct if you used this guy, but it would be improper scientific notation. Here's our fourth problem. This time we have grams going to milligrams. There are 1,000 milligrams in 1 gram. So I'm using dimensional analysis for this problem. 0.245 grams. I want my 1 gram in the denominator. I want my 1,000 milligrams in the numerator. Multiply by 1,000, you get 245 milligrams. I'm going to go back and cancel my units to prove that milligrams are the units I should have. Centimeters to micrometers. First, let's set up our ratios. There are 100 centimeters in 1 meter, and a micrometer, a micro means 10 to the minus 6th, so that means there are 1 times 10 to the 6th micrometers, that's the abbreviation for it, in 1 meter. Okay, so we need these two conversions. We're going to start with 0.0381 centimeters and convert them to meters. 1 meter on top, 100 centimeters in the denominator. Notice my centimeters cancel, and I'm at meters. Using my second conversion, 1 meter has 1 million micrometers. Again, did you put things in the right spot? The meters go away, I'm left with micrometers. Now if you do the math, 0.0381 divided by 100 times 10 to the 6th, you should end up with 381 micrometers. So check that out on your calculator, see if you can be successful. Now we have a three-dimensional one, and just wanted to bring this to your attention. We have 0.45 cubic meters to cubic centimeters. So you know that there's 100 centimeters in 1 meter. So let's see how we can convert a volume from cubic meters to cubic centimeters. So we're starting with 0.45 meters cubed. And if I set it up first, just the way we have, with 1 meter in the denominator and 100 centimeters in the numerator, if I look at my unit analysis, I'm still going to have, if I cancel these meters, meters squared here. So I need to do the conversion 3 times before it will cancel. Once it's cubed, that'll give me meters cubed and centimeters cubed. Another way of writing it is to do 0.45, since you're new at this, meters cubed, and I'm just going to write it 3 times. 100 centimeters in 1 meter times 100 centimeters in 1 meter times 100 centimeters in 1 meter. So it cancels it 3 times. 1, 2, 3 to get centimeters cubed. This upper problem does the same thing. Once you work your magic, you should have 4.5 times 10 to the 5th cubic centimeters. There's your final answer. Do box your answers. Really helps. Me at least. All right. One more problem. This is a density. Density is a mass over a volume. We start in grams per cubic centimeter, and we're going to cubic meters. So we're going to start with 13.534 grams. I'm going to write it over 1 cubic centimeter like that. Now, there are 1,000 grams in a kilogram. That's on your blue sheet. And as we just worked with, there's a 100 centimeters in 1 meter. So, let's change grams to kilograms. Kilograms on top, grams in the denominator, 1,000 with 1 on top. That takes our grams, change them to kilograms. I'm going to put 1 meter on the bottom and my 100 centimeters on top, because I want to change what's in the denominator. I'm going to cube those. By cubing it, I'm going to say that's going to end up cubed. So I'm going to get rid of, oops, let's go backwards. Didn't want to do that. See if I can, do that, and I think I'm going to have to start again. Yeah, it's not there. So let's go back to 13.534 grams per 1 centimeter. Sorry, I have to rewrite it. Let's change our grams to kilograms and do our cubing. 100 centimeters in 1 meter. So centimeter cubed. All right, let's cancel properly. Oops, I forgot cubic right there. Cubic centimeters will cancel. We'll end up with cubic meters. Grams will cancel, and we'll end up with kilograms per cubic meter. Do your math. Check it. Do you get 13,534 kilograms per meter cubed? And you can put that in scientific notation if you want it. All right, that's it for conversions. We'll do this practice all this week.